Idea of random number generators. Now, a very important construct which goes into the overall simulation exercise. Now, random numbers are required because we need to have a random sequence of values which are required as a part of the simulation exercise. So remember the equation for ds whereby we had the phi in the equation, right? So that phi is that random increment which we are interested in, and that is something which we draw from a distribution. Now, commercially available random number generators are what we call as pseudo random number generators. Now, the most popular of the lot, I would say, is the UDF, as I had earlier mentioned, a U01 distribution, because this is something which you find commonly available in most commercial calculators. And the beauty of U01 is you can take this number and you can transform this into, let's say, a standard normal distribution as required. And that way you can use it as a part of your computation. So for readers who are familiar with the rand function in Excel, the rand function also draws numbers from a U01 distribution. Now, as a part of the random number generation, there is one concept which we call as a seed value. Now, unfortunately, in Excel, we can't set a seed value. So if you're doing simulation in Excel, this concept of seed does not exist. So I'll explain what a seed means. So we require a seed value because we want to freeze the instances of random number generations which is happening, i.e. we are trying to freeze on the sequence of random numbers which is generated. So that is, if I set this seed to be equal to, let's say, 100. Now 100 is just some number. Now 100 doesn't have any specific, so in case I'm using the simulation for options pricing, this 100 doesn't have any impact on that. 100 is just something which I'm telling the system. So when I set a seed equal to 100, then I'll have a certain sequence of random numbers which is generated. And the thing is, when I define this kind of a seed, that sequence at which that random number is generated, that remains exactly the same. So even if I rerun this simulator n number of times, it will ensure that the same sequence of random numbers is generated. And that happens whenever we set a seed value. In software like Python, etc., we can have a seed function so that we define the seed and we are able to simulate random numbers which follow that same specific sequence. Now, a few advantages of the recurring nature of the pseudo random number generator. Now, the same set can be used across a large set of products. So imagine that you have a large portfolio and you can use the same random numbers everywhere. Also, once we set a seed value, it makes our life very easy for us to meet any kind of audit and compliance requirements. The thing is, let's say you have done an option pricing, you put in the option pricing value as a part of your report, and that report goes to the regulator, or maybe let's say your auditor. Then auditor may come back saying, okay, so we see your options price, but can you tell us, or can you maybe show us how exactly you came up with this price? Now, if you haven't really set a seed value, the moment you open your calculator, your values will be different. So your auditor, in case they don't know what the concept of random number generation, they may just quickly say, I mean, your simulator is incorrect, but that's not the case, isn't it? So at that time, what you do is you set a seed value first and then you run your simulation. So you set your seed value, you run your simulations, use that in order to then come up with your option price and use that price as a part of your report. So that once you set the seed value, as I mentioned earlier, even if you run the same simulator n number of times, you're going to get the exact same options price. And that way, all of the audit and compliance requirements are met as well. Also, random number generator can be used as a part of cluster computing or also what we popularly call as grid computing as well. Because the thing is, the same seed is something which can be allowed to be used for simulation across different products, which could be sitting across different portfolios as well. So maybe imagine a large portfolio whereby you're working on, then you can have the simulation which has been just done once, and that is something which you can directly consume for all of your instruments which are of similar nature, which form a part of your portfolio. So that way it speeds up the process greatly. Other ways to speed up these things are also using the ideas of parallel processing or what we call as parallel computing as well. So something which industry participants frequently use whenever they are working on very large number of simulations, because that way you need to have more number of such random numbers. So at that time, parallel computing comes very useful.